Hi, Mr. Bouchard here, and I'm here to talk to you about what are the physical and chemical properties of matter. So we're going to be dealing with the physical and chemical changes. So just to give you a quick little example, okay, this marshmallow right here is on fire, okay, and obviously being on fire, it's creating a little soot on the outside of the marshmallow. Okay, that basically is a little reaction that's happening. So once the marshmallow material burns off and becomes that soot, it can't be reversed. So that's what we call a chemical change. On the other hand, we have what's called a physical change. So in the case of ice, okay, ice still is actually water. The only difference, it's a different phase of matter. And when it melts, it turns into liquid water. So that's what we call a physical property or a physical change, right? Because it's basically still the same material but has not chemically changed. All right, so we're going to talk about these differences and go a little more into detail about this. Okay, so properties of matter. So physical properties are all the observed characteristics of the substance without changing it into a new substance. Okay, so an example of that, I already said, melting point being 0 degrees Celsius. That is a physical property. Freezing point also being 0 degrees Celsius. So remember, freezing, melting point are the same temperature. It's just whether you go above or below that number determines whether it's going to be freezing or melting. And then we have boiling point, which is 100 degrees Celsius. All right, and that also is a physical property of matter. Okay, physical properties can also include a list of things. Okay, so number one could be their color. All right, so when we look at an object, obviously color comes to mind right away. First obvious thing. Texture. You can notice some of these different metals here. Some of them are more rough looking, some of them are more smooth. Okay, hardness. Some of these are super hard metals, which make them very useful for certain materials. An example, steel. All right, steel is used for really strong materials. Aluminum, on the other hand, is a weaker metal but very light, so it's used in other applications because of its lightness. Luster. So some of them are very shiny, some of them are more dull in this case. And also flexibility. So I already mentioned aluminum. You can actually crumple that up into a ball. You can shape that in any way. And that's why it's used for many metals, because it's super light and shapeable very easily. So we use aluminum with a lot of things nowadays because of that. Okay, on the other hand of things, this is called Alka-Seltzer. So Alka-Seltzer is basically a medication that you put into water and it starts bubbling like crazy. Okay, so chemical properties are characteristics of the substance describing its ability to change into other substances. Okay, so once this Alka-Seltzer touches the water, starts bubbling, it's basically creating a new solution. It's basically making a Alka-Seltzer water in a way. Okay, there's a lot of bubbles in it. It's actually meant to settle your stomach, so it's a way of it dissolves in that water to become a part of that water, so it's easily to drink it. So that's a chemical change. Okay, substance must change to observe its chemical properties. Okay, so again, when it's changing here, the bubbling is happening, you know there's a reaction going on. Okay, on the other end of things, chemical properties, all right, we have burning, all right, rust, all right, these are all chemical changes. They're not reversible. Once you burn something, it's not going to come back, all right. Once the fuel is spent, it's gone. So wood, once it's burnt, you're left with soot. You can't turn it back into wood again. Same thing with this rust and this spokes of the wheel here. Once it's rusted, you can try to restore it, okay, but in general, that metal is now compromised. Okay, we could also have tarnish, right? That's another type of breaking down in the material. So silver sees this. Silver will actually turn black when it is exposed to air. So you have to actually polish it on a regular basis. All right, so all based on the types of atoms in the substance. So chemical properties are all based on that, and that's how we know we have a chemical change going on. All right, so basically you'll see some changes in the substance, whether it's color change, whether it's changing to a total new material that you notice. That's definitely a chemical property. Okay, so physical changes are changes in appearance of the substance without changing it into a new substance. So this can include size, shape, texture. So example, cutting wood. All right, you split the wood into two pieces, it's still wood. You just made it into a smaller piece. Even if we're shaping wood into something, all right, using a sander or something like that, you're still not changing it chemically. You're just changing it physically, and that's it. Water again. So ice basically is solid water, and the liquid water, remember, it's still water. It's still H2O, even if it's solid or a liquid. So melting, freezing, vaporization, liquid changing into a gas, bending, breaking, crushing. These are all examples of physical changes. Okay, on the other hand, chemical changes is changing a substance into something completely new. All right, so great examples. Obviously the burning marshmallow, which I said earlier. The rusting bike wheel, again, so it's going to change into something new. That rust material is a new material. And firecrackers, right? So the stuff in firecrackers, that's a chemical reaction, right? But once you run that chemical reaction, it's not going to go back to its original form. All right, so burned marshmallow, rust. All right, and so anything with a chemical change is caused by a chemical reaction. And again, it's not reversible. You're not going back at any point. So once that chemical reaction happens, you can't change it back. All right, so how do you know a chemical reaction has taken place? So there's certain things we look at when something is going on. All right, so number one, you can see a formation of a new substance. Okay, so maybe in the case of a liquid, it will change color, right, as an example. Burn crust on a marshmallow. All right, so the outside of that marshmallow turns that brown first and then finally black. So again, you're forming your new substance. Bubbling. So when you mix two things and it starts bubbling, that's usually the indication that something is happening chemically inside the material. Okay, so an example of Alka-Seltzer, again, the bubbling happening definitely is telling you the chemical reaction is happening. I mentioned color change already, so you can see the color change in some objects when they start changing. So an example, the rusted bike wheel goes from the silver to the more orangey brown color that we know as rust. Okay, and then lastly, this is something mentioned in the chapter. So what's the difference between matter and energy? So matter is made up of atoms, right? So it's something that sometimes is tangible, sometimes you can feel it. Sometimes air, obviously, is matter also, right? So it's made of particles, okay? Whether it's a solid, liquid, or a gas. It takes up space, volume. That's how you know you have matter. And it's definitely not energy, right? Energy is something that is transferred, right? So we're going to talk about that more. Usually an object or a substance, matter. All right, energy, on the other hand, has no mass, okay? Does not take up space, and it's actually used to change matter. And that's pretty much everything here. So thank you guys for tuning in, and I'll see you next time.